Hello, everyone. Welcome to today's panel on the growing role of open source technology in today's data architectures. Today, we have probably the most amazing panel put together in any data conference period. So let's get into it and do a round of intros. So first, I'll introduce myself. My name is Vinoth Chandar. I'm founder CEO at Onehouse. My life for the past 5-6 years has been around unifying data architectures, data lakes, data warehouses, stream, batch processing, and that's kind of like what I do. And with that, let's get into our panelists. Start with Raghu. If you can wave for our audience, so we know, that'll be great. So Raghu is as accomplished as they come. Raghu's been a academic. He's a professor at the University of Wisconsin and chief research scientist at Yahoo, now technical fellow at Microsoft and the data CDO at Microsoft as well, and overseeing large parts of like Azure and data services. It's an honor to have you here amongst us, Raghu. Thanks for making the time. And we go to Jay. I think Jay needs no introduction. Jay Kreps, CEO at Confluent and also the co-creator of Apache Kafka. Jay has created pretty much a new data infrastructure category in the industry, stream processing, over the last 10 years. So Jay, thanks for making the time. And we also have Justin Borgman. Justin is one of my favorite entrepreneurs, founder CEO at Starburst. Justin spent the last 10 years starting, from his journeys at Adapt and like how to marry like data lakes, open formats to SQL-like engines and working at that intersection. So he has a ton of experience and the stories to share with us today. Thanks, Justin, for being with us. And we go to Kapil, and Kapil Sulekar, VP of engineering at LinkedIn. Kapil's been like a constant force shaping LinkedIn's data infrastructure over the years. I've seen Kapil run operational databases, analytic databases like Hadoop and what have you at LinkedIn, and he's funded like about a half a dozen projects in open data that we all use. So thanks, Kapil, for doing that and also making the time today. And we go to Praveen Naga, VP of engineering and data science at Uber. And as an engineer, Praveen built actually one of the earliest real-time analytics systems that we use today. And now, several years later, Praveen now runs one of the most critical platform teams and at Uber. So thanks for being with us, Praveen. And finally, Justin Levandoski joins us from Google Cloud. And Justin works on the Big Lake analytics team at Google and working across, Big Lake, the intersection of Big Lake, BigQuery, open data formats, and there's been a lot of work coming out of that area. And Justin has a great research background, starting from Microsoft Research and then as principal engineer at AWS before this as well. So, folks, this is going to be like very, very exciting panel, and we're going to cover a lot of ground. So, strap in. All right. A lot to kick things off here from a broad perspective from Raghu. Given your vast experience in the industry, how have you seen the perception and adoption of open source change within enterprise context, from like a hobbyist kind of thing to something that's like mainstream now? And what do you think is kind of causing that change to mainstream?
Well, this could keep me going for the entire panel, but I'll try and be brief here. So my first experience came when I was at Yahoo, back in the days when we were all working on Hadoop. And a big reason we did it, we realized we needed to build new infrastructure at some scale, complexity. We didn't want to do it by ourselves. And by making it open source, we got buy-in from a number of companies in the Valley initially and elsewhere later. And many hands make light work. Many hands also mean broader adoption. Our systems got field tested early and often. And from there, it just became the thing. When a new project started, why not open source the default? It was helped a great deal by the fact that Yahoo wasn't trying to monetize these platforms directly. We were monetizing something else, viewers who came to the portal or such. So the fact that it aligned with our business model made it easier. But once we got the ball rolling, the Valley in general got really on board with open source, and it became a thing. If I fast forward to today, I see this having great ongoing value for multiple reasons. It is, I think, the best way we have today of creating standards, right? Standard interfaces, standards for interop, standards for benchmarks we can all agree upon and commonly measure the systems we rely on. So customers love it because it insulates them from vendor lock-in. And I think even enterprise companies like Microsoft, we embrace open source because I think of the benefits we see in standardization, right? So that's my take on open source and why it's so important and continues to be.
That's actually an amazing perspective on how the origination of open source and kind of large tech internet services companies kind of like have a role to play in that, right? So with this, I want to go to you, Kapil. LinkedIn has been a significant contributor to open source projects like Kafka, Samza, Data Hub, Pinot, Voldemort, which is two of us worked on that project here in this room. And what drives this commitment to open source, and what drives LinkedIn's decision to open source something?
Yeah, and like I said earlier, I've been lucky enough to be associated with many of these open source projects at LinkedIn over the past several years. And I would probably hit on some of the points that Raghu also talked about, right? I mean, each of these projects that we built at LinkedIn obviously started with a real need for those systems, not a desire to open source it necessarily from the beginning. But as part of the evolving culture, I think it definitely helped that, hey, we were not looking to monetize any of these infrastructure systems, but we realized that we could get several benefits from open source, right? So one, of course, I mean, it does help tremendously in building your engineering brand, right? And several of the super successful open source projects we've had have done a lot in terms of building our engineering culture and engineering brand. Right. And in addition to that, it does help, like Raghu said, in terms of, creating those standards. We see better quality of software, not only from, the encouraging developers to be more conscious of the code they put out there, which is natural, right? You have a lot more eyes going on to your project. You're going to be a little more careful about what you put out there. But you also get sort of the benefit from, the testing and the adoption that you will get from the broader community. Exposure to that broader community also holds the developers more accountable for what they're putting out there. And for engineers also, I think it's a continuous learning and skill development. This is something that they can be associated with over their career, maybe through several companies, right? And involving in the open source, whether they created them or they were active committers in projects that somebody else created. Either way, I think it does help in their personal brand, in their learning and skill development. And I think these several factors encouraged us to think about open source, and I think they continue to be true since then.
Got it. Praveen, I would love to go to you and maybe like take you way past and down memory lane, and maybe like a quick take on from an engineer like kind of standpoint, right? Like what made you passionate about open sourcing something? Like, because ultimately the engineers have to build it, and they have it's a grassroots thing for a successful open source project to come out, right?
Yeah, I think there are a lot of points Kapil said. First of all, I work with a lot of you folks very closely. And of course, Vinoth, both at LinkedIn and Uber. And what I would say, first things first is, I know I was super inspired by what Jay was doing at LinkedIn those days. You guys remember this Web 2.0 wave? One of the big things with Web 2.0 is data. We didn't even know how to handle that traffic. I don't know, Jay remembers that 2008 time when financial crash happened, and suddenly we got a string of traffic coming in. We couldn't even keep our site alive. And watching Jay, I had the front row seats, guys, and watching him think about these problems and how he actually came up with Kafka, the logging framework that is a real need, as Kapil said, for the company, which really inspired me. And for me, it was like, as Kapil said, like as an engineer, I wanted to do something as well, right? And I was very inspired. And one of the problems I've been thinking at that point was LinkedIn had this need of online analytics products, right? And I think we were struggling because we were using MySQL and all these things, which were not so natural in nature because it's temporal data, large volumes of data, and so forth. So that's how this Pinot came up. And again, Jay, I don't think he remembers, he's done a lot of things in his life, but he actually helped me out, gave a lot of advice of how to stitch together distributed systems into it, and build a Lambda architecture and so forth. So I wouldn't trade any of those experiences, which actually made me what I am right now. But anyways, that's how Pinot started, and a lot of things happened after that. Now it's a pretty widely adopted community thing, and even at Uber, we are pretty much a Pinot shop.
Got it. Cool. That's so awesome to hear. So this zooming out a bit and back, talking in like industry and open source, right? So I want to go to like Justin at Google. Like, so you've been pretty busy this year, like with a lot of announcements around Big Lake, governance around open data, interoperability for BigQuery across even non-Google Cloud storage. And I personally love all the moves that BigQuery has made to open up more integration points on open, for the open data formats like, Hoodie and like Delta Lake and things like that. How do you see the relationship between proprietary software and open source in this space?
Yeah, thanks for the question. I think BigQuery's in an interesting position because if you look, go back to the original seminal paper on Dremel, right, which was published in I think 2010, right, at VLDB. It kind of started its life as the original data lake for a query engine for Google, right, and slowly but surely it was built out into BigQuery by clean separation of compute and storage and disaggregated memory for shuffle and so forth. So given that kind of architecture and background, right, starting, I guess, 3 years ago, and kind of back to the genesis of Big Lake, we actually started hearing from customers, GCP customers, that they wanted to build their data analytics foundation around open source formats, right? But they wanted essentially to solve the hard kind of data management, kind of common data management problems that you see kind of again and again, right? These are things like governance, metadata management, so on and so forth. So the architecture of BigQuery, we started kind of extending the pieces here and there to provide these common kind of, I guess, architectural primitives that you could provide these common kind of data management solutions for either whether it were proprietary storage in BigQuery or open source kind of formats, data lakes, whether it be Parquet, Delta Lake, Iceberg, so on and so forth, right? So we not only extended kind of BigQuery's support to provide open source formats as a first-class citizen in BigQuery, but started extending pieces through our kind of storage APIs, so on and so forth. So other analytics engine, open source analytics engines like Presto and Spark were able to take advantage of these same advantages, right? So this is where I saw things kind of converging, and with the start of the Big Lake team.
Got it. That's very interesting to hear. I want to go to Justin. So we talked about a lot about open source projects, and a key open query engine in the market today is Trino. And how do you see Trino fitting into the broader cloud landscape, along with like other query engines, warehouses? Because Trino is kind of like interesting in that it supports both the models, right? So how do you think about an open query engine in this ecosystem?
Yeah, well, I mean, consistent with a lot of the themes that were already mentioned around, avoiding vendor lock-in and interoperability and really providing customers with optionality. I mean, these are sort of all of the design criteria behind the creation of Trino. And for those who aren't familiar, Trino was born originally at Facebook as the Presto SQL engine. Later, Presto SQL became Trino, and that's the project that is booming today, if you will, and used by many large companies like LinkedIn, for example, as well as others. And the truth is, part of what makes it unique is the fact that you can query data just about anywhere. You could have data in any proprietary database, just about any open source database, NoSQL database. You can query topics in Kafka, for example. And so it's incredibly versatile. And so this idea of giving customers flexibility and optionality and avoiding lock-in, that's really what it's ideally suited to do. And what that translates to is a lot of customers end up using data lakes to store the majority of their data, and increasingly are using open data formats like Hudi, for example. And the combination of something like Hudi and a query engine like Trino is effectively an alternative data warehouse. And what we're seeing is that companies are increasingly, I think, reacting to the proprietary nature and expense of traditional, cloud data warehouses, obviously Snowflake being the big example, and looking at ways to create alternative architectures that don't lock them in. And, we kind of saw this movie play out a little bit, maybe 10 or 12 years ago with, Teradata and the advent of Hadoop as kind of the first data lake. And I think this movie is just replaying itself again now in the cloud.
Very few people, I think, are around who saw the first Hadoop EDW thing and then now are seeing the Lakehouse vision, I think. It's kind of like interesting how it repeats itself.
Are you saying I'm old, Vinoth?
I am too. I know that as well. So I am old, but I have a hard time explaining to people sometimes that it's actually happened before.
Yeah.
I mean, you guys competing about who's old.
All right. Cool. Next, I'd like to switch some focus towards data architectures. This is going to be like a fascinating conversation given the technical depth on this panel. Yeah, so earlier this year, Raghu, this is for you. Azure had heads turning with announcements with One Lake, Fabric, and we're now going to talk about one table at this summit as well together. Can you please tell us about how this kind of like, affects data architecture at large? There is, the compute unification sort of like interop, there's like data, there's like many things going on there. Please enlighten us.
Yeah, there's a lot of things going on there, but there's one silver thread that runs through it all. Ultimately, our customers are enterprise customers, and most of their users are domain experts, not SQL or Python or Kafka or any of the tools that we think about. So our primary goal is to democratize access to all of these capabilities. Not dumb it down, but make it easy to approach. And so if you look at what we are doing, there's one format underneath. That's an open Delta Parquet format, okay? All our engines, the ones that are part of the Fabric ecosystem, we have re-engineered to work natively on that one format. If you look at governance, all our engines are governed using Purview. Underneath, right, it's always on. These are our efforts to make the product uniformly plumbed, simple to use. But then let's turn around and look at what that means from a adoption, vendor lock-in, interop perspective. While we can't standardize everything within our control, the rest of the world has its own standards, its own formats, its own everything. And some of our customers want to come in and just use whatever we offer. Others want to pick and choose. And we want to let them choose. So the way we deal with this dichotomy, while we deeply integrate, we have been very, very committed to open standards at every layer. Our data, as I just said, open. If you think about governance, Apache Atlas, I could go on and on. But basically, our streaming stuff, we comply with Kafka patterns. So across the board, we are trying very hard to make sure that our surfaces are standard, right? Even when some of the tools are proprietary. And ultimately, if you want to keep your data in One Lake, it's open. You want to bring Trino to run on it, go for it. You want to bring any tool that understands that open format, go for it, right? So that's, from our perspective, a major use of open standards. Likewise, when we benchmark anything, the tools, the benchmarks themselves, we open source, LST bench. Earlier, when I was at Yahoo, we did the same thing with YCSP, right? So the point that, Justin just made about Hadoop and Teradata, look, I think the real issue is going to be, do customers feel locked in? And equally, if customers need to stitch everything together from independent tools in order not to feel locked in, for many of our enterprise customers, that's not attractive. So we are trying to cater to a customer who doesn't want lock-in, but at the same time would like something that meets 80-90% of their needs off the shelf, in a way that their typical domain expert user can use, right? So that's kind of what we are trying to do and how we think open source is a key part of it. Open standards, more generally, are a key part of it.
Interesting. So it's like a blend of flexibility to use with the product experience to be productive, or what you're trying to do.
Ultimately, for us, it's all customer backward. Easy, no lock-in. However we can meet these two goals, that's what we're trying to do.
Amazing. So we spend a lot of time talking about data at rest and even in illustrations, right? But how data moves is another very key aspect in data architectures, right? And because like we talk a lot about lock-ins, that's kind of like how lock-ins are created to begin with, like closed data pipelines, dumping data into proprietary data warehouses, right? At least that's what I've seen. When we think of Kafka, we think of stream processing, but an equally significant outcome is how it's now democratized open data streams for everyone, right? So, Jay, can you tell us more? Was this like an intentional goal when or like it was like it happened?
Yeah, probably a little bit of both. I mean, it was definitely an intentional goal to make something that was kind of the one stream to rule them all. Like at LinkedIn, speaking of the kids these days, but yeah, indeed, we had big Hadoop clusters and people whose job it was to go scrape all the data out of all the systems and put it in Hadoop. And then we had these analytics projects, and the goal was, go scrape all the data out of databases and get it over there for this recommendation engine, and go feed this search system. And it's just a lot of duplication, and kind of at each layer you got a team of people whose job is to try and be downstream and clean up the data and get it into shape. And so the more you can push that upstream and kind of publish something good that has some contract that everybody can subscribe to, the better. And, it just kind of makes sense. Like, we were at LinkedIn, it's a digital business. It's generating data all the time. Didn't really make sense. You got to go scrape it out of systems at, midnight Pacific Standard Time as the only way of getting things. And, if you think about what's useful to that kind of business, having some kind of more real-time feedback loop where you can process something and act on it right there, that's a lot more natural, a lot more likely to be able to feed back into a customer experience while they're still there. And so that made sense. And we thought it might make sense for other people as well. But of course, you don't really know till something gets out there and, you see it get used or you don't see it get used in other industries and other types of application. And yeah, indeed, it turns out this stuff is, at least as big a deal outside of the tech industry as it is in tech. And that was really exciting for us to see. I always think one of the most fun things about both open source, but also any company that sells technology across industries is going and seeing it, play out in each of these types of companies. What are they doing? How does it fit into their business and their business model? That's probably one of the most fun parts of my job.
But that scraping job still exists. I think I still see a lot of people doing that even on cloud. So I think we have a lot of work. I have to probably fix that. Cool. That was interesting. So I want to go to like Justin at Starburst. So bringing all forms of data to a single platform with universal access, federated, that's been like a dream of yours from the Hadoop days, right? Like speaking about, again, this movie's playing the sequel. So is the sequel the thing? Like, is this going to happen this time? What do you think?
Yeah, I mean, I think certainly in terms of data in data lakes today, the biggest change over 10 or 12 years, there's probably a couple changes that are important from the first data lakes with Hadoop and where we are today. One of them is certainly the formats themselves have greatly improved in terms of their level of optimization. We use columnar formats now to get great read performance, and they support updates and deletes. So like the functionality gap between a traditional data warehouse and what you can do now with a query engine and open formats, that gap has closed dramatically. The other thing is the engines themselves, like Trino, have matured significantly. I mean, it's been almost a decade now since Trino was first created, and it has to run at the scale of Kapil's organization, right, or Facebook, or Airbnb, or Netflix, or what have you. So these are really like battle-tested engines now at this point that have all the bells and whistles, cost-based query optimizers, and all of that just takes time. I think like in the early days of Hadoop, we probably oversold the capabilities of those early Hadoop engines back then. And the reality is like building a database is hard, and it takes years to build all those pieces. And a query engine is like all the hard parts of a database, the execution engine, the cost-based optimizer. So we're now at this point, fast forward like 10 years ago, it may seem like a short period of time, but a lot of work has gone into these things where you can credibly run an alternative data warehouse with performance that's nearly identical without the lock-in, without the cost and expense. And I think that's game changing, and it's real. It's really happening now.
Yeah, that's awesome. So yeah, I think it's slowly from at least from what I see, it's turning into almost like a universal kind of like a maybe a USB hub kind of like model where you're like a standard interface, you plug and play in query engine, the same data with different, that's another thing that I'm saying. I want to switch over to like a little bit to Praveen to get a practitioner perspective. So we've been like hiring a lot from like the cloud providers, the vendors perspective, right? So Uber is a very unique data company. I also lived that era at Uber. It requires real-time data, but massive scale. Like a combination and operating cities and data science efforts, and you do critical things like matching supply demand, right? So how have you architected with open source data over the years? Are there tools, platforms that have been like particularly impactful to get Uber to where it's today?
Yeah, I think so. Uber is a unique company because it formed at a time when a lot of open source stuff has been there, but and getting out of companies. So it was a situation where we are able to leverage a lot of open source, but the company needs were extremely real time, as you said, right? It is a company where the physical world and the digital world meet each other. And when you hit that button, a lot of things have to happen, right? What we call as magic. But as Vinoth said, matching has to come in to figure out which are the drivers to do, what is the pricing we should do, and what is the risks and frauds that happen across the world. And then you have to do the mapping and routing, ETA calculations, and all this has to happen in real time. The models have to be built out for all these things. So it was pretty complex right from the beginning. It is not like we evolved into this product, but the product actually started from there, right? And the reason why we are able to succeed and scale is because of open source. If we had decided, hey, we're going to do everything ourselves, I don't think this company would have existed, honestly, right? So not just in data, but all the other space, but specifically in data. Then what happened is, the real-time needs is actually very real, where operations on the ground need to actually be able to see what trips are happening and how drivers positioning and stuff. So then we have to make these payments to the drivers. There's millions of drivers on time, right? And these folks are coming to our platform to earn money. So anyways, this is where Vinoth was very much involved in actually creating the transactional data lake as a concept to begin with, right? And that became a streaming transactional data lake, and that's where Hudi came in. And I would say that's been our biggest benefit, where we are able to run this data lake in an efficient manner and provide real-time insights for all these different domains that I talked about. So I'm glad to know that, Hudi is one of the leaders in this space and how you're pioneering in this space and helping people. Anyways, that's kind of what I would say.
Good to hear that. But yeah, thanks for the perspective. I think it's still Uber's been used as like a case study for like interesting data architectures. I think one of your teams was very recently in one of those kind of research articles as well, right? With how you do fulfillment across cross region and those things. So it's a lot of interesting work still going on. So it's great to see. So Kapil, we touched upon this thing about the right query engine for the right workload, and for me, I've always had that. Like even back at LinkedIn, we used to use like MapReduce, Pig, and something else, and came to Uber, we used like Spark, Flink, Presto, Vertica, like bunch of other engines again, right? So do you think it's more of a need or a want? Like, is it just some mostly things that you think the bigger tech companies should do, or what do you think is stopping people from picking the right engine for the right workload out there at large?
Yeah, that's really a great question, right? And you probably remember for LinkedIn days too. It's like early on, it was just Oracle, and that was pretty much it, right? So we've definitely evolved from like, hey, one size fits all to an explosion of query and compute engines, which are much more specialized. And that was all through absolute need, right? And you probably remember, like, even when something like Pinot was created, we probably used like every single thing that was out there to see if it would work. So I think using the right query and compute engine for specific workloads is absolutely a need rather than just a want, right? And I think there's multiple reasons for it. One is obviously you have a diversity of workloads, like some you need real-time data, some you need more historical, some you need much faster query performance because it's side-facing, cost, and hardware utilizations. You kind of have to balance all these things, and it's really hard to find a single engine that's just going to do it all and that ticks all your boxes, right? Now, of course, like there is a cost to it, right? Every time you get a new engine into your ecosystem, you have the complexity of integration, you have the complexity of learning curve for your engineers. If it's a proprietary system, you have the potential risk of a vendor lock-in, and all of that stuff. And I think to me, one of the biggest blockers in kind of enabling that is really the data consistency and compatibility problem, right? So if you like, typically a lot of these query engines are coming with their sort of data formats and expectations kind of locked in, and therefore you have the situation where one engine can't read the data that is maybe created by another, or they are duplicating, and therefore you get different answers sometimes based on which engine you go to. So I think the open standards and compatibility, I think, is really probably the biggest thing that needs to be focused on enabling this, right? And that's probably the reason why people are not able to pick and choose the right compute and the query engines for their workloads. And that's why I think, like hugely appreciative of projects like Apache Hudi, obviously, right? So I think like disconnecting those data layers from the compute and query layers, I think is the most critical factor in enabling that innovation.
Got it. That's kind of very, very insightful. I do remember we used to serve everything out of a key value store, including as a cache, as a like our profiles and images and everything else. So yeah, definitely can relate to this. I want to quickly move to a build versus buy and discuss like because 10 years ago it's you pick open source projects and you build, or you buy a managed service, right? That was build versus buy. Now today's ecosystem, you actually have plenty of options. You can actually, even within open source, you can buy a managed service that builds on top of the same open source technology, right? And also you can take open source off the shelf and build it yourself as well, right? So this option exists. So I want to just go through our panel and kind of like explore this a little bit more. So I'll start with like Justin at Starburst. So you've seen some large companies do some amazing things with Trino, the open source project. what are the things that you see them succeed at just by doing, off-the-shelf open source? And what are some of these like primary challenges then they run into?
Yeah, I mean, I think it depends on maybe a combination of factors, both the use cases as well as the size and sophistication of the company. And I think, for companies that have significant scale, and particularly have significant scale of their own data engineering organizations and have their own very specific requirements, then leveraging the open source makes a ton of sense. It's infinitely flexible and extendable, and you can modify it yourself and run your own private fork. And a lot of companies that do that for sure. I think where people get stuck is if you're not in that category of company, you might need to integrate with a whole ecosystem of enterprise capabilities that open source developers generally aren't inclined to go build and then further troubleshoot, things like SSO or role-based access controls, attribute-based access controls, query auditing, all the kinds of things that regulated industries really care about. So I think that's where you see, just to stereotype here, a large financial services company is unlikely to want to run open source entirely on their own. They have too many enterprise capabilities that they need really from a platform. But they still like the optionality of knowing that they could if they had to. There's always that off ramp, as opposed to maybe somebody like, again, LinkedIn, that has exceptional data engineering team. I mean, I think many of you are alumni clearly, and can run this stuff themselves.
Got it. So it works both ways basically. Like you can go from managed to proprietary or back. So that's very interesting. Jay, I want to give a very similar take from you. So you actually been in like some of these bigger companies. You've been on the other side. You purchased like vendor software, been in these critical decisions, right? And now we're seeing Confluent Cloud grow leaps and bounds, and Kafka continues to add major improvements in open source as well, right? So if putting yourself in the same shoes before, right, what framework should one use when deciding between building in-house DIY and just off-the-shelf open source versus using a managed service?
Yeah. I mean, I think the world has changed a lot. At LinkedIn, it was definitely a set of in-house things and, things from open source we would bring in when I was there. And that was kind of the best, that was the best option available. But, just the set of companies that are running out of the public cloud, that's increased. Early on, it was maybe a lot of small tech startups. Now it's, increasingly everybody. And that does mean it's kind of a free market competition of different infrastructure layers and query engines. And, every idea around data is being pursued by somebody. A bunch of great stuff from the cloud providers, a bunch of stuff from independent companies. And so, yeah, the ability to get something that's fully operated for you and has a ton of functionality, is heavily optimized, is fantastic. And I think it's very appealing. It doesn't mean there's no point to the open source, both because people love an open standard and because it gives you kind of a good exit to do it yourself if, the vendor isn't doing a good job. But I think the set of companies that are now addressed by managed services is just much higher. And that bar to kind of build a team out internally and really produce like a quality user experience for the internal users, that just kind of goes up every year as the tools that are available externally go up. And I think there's kind of a fundamental economic reality to that, which is, you can invest more if you're doing it, trying to solve the problem for all the companies in the world than if you're trying to solve it for one. But nonetheless, the new stuff, the new open source projects still often come out of companies that are doing a lot of in-house development. So it's a, kind of a special place for those. So yeah, I think the skill set in this area has changed. If the data engineer or, large scale database person of the past was mostly about how do I take an open source product and run it, or how do I build something from scratch? Now I think the buy component of that is actually quite important, of just like, hey, how do I evaluate different existing services, pick something I'm going to be comfortable running off of for many years, make sure I get a cost-effective deal out of that, and how do I trade that off against kind of doing it myself? that didn't used to really be a main option if you're running out of your data center and you're at scale where there aren't a lot of vendors who are going to really come solve your problem for you. But now I think, at any scale, that's effectively a very viable solution. So, and we're seeing that, I'd say for Confluent 2-3 years back, it's a bit of uphill sledding to get tech companies interested in a managed cloud service from us, and that really changed. I think just increasingly there's efficiency pressure on these companies, and they're kind of looking at like, hey, where are our best engineers spending time? And there's some systems which maybe give them a competitive advantage and keep them ahead. And there's others where it doesn't, and they just want to get something that's really good and not worry about it. And that really is I think a pretty significant change in behavior. So yeah, I don't think there's a hard and fast rule of always build or always buy, but I think the buy is becoming a much bigger part of things, and I think it's because of the cloud.
All right, that's fascinating. I will get go to Justin at Google and get a sense from an data consumer perspective, right? Like if you look at something like BigQuery, it's generally people love it. It's an easy experience. It's like easy to use, things like that. Is that the key buying criteria beyond kind of like platform teams? If you look at your users, like what do you think they value? Like platform teams value a lot of open data and all these things, but to the normal user, is open data something that they think about in their buying process, or it's like experience and cost and performance?
Yeah, well, first of all, Vinoth, thanks for the plug for BigQuery. And yes, I mean, generally we do see, customers come because of the ease of use, right? And I think this is because of the, if you look at managed cloud services, right? Generally, back to Jay's point, right? We've matured as an industry such that, most services these days that are being consumed in the cloud hyperscalers as cloud services are, generally serverless, multi-tenant. For BigQuery, customers just have to bring us their data and start querying data. We can auto scale behind the scenes, so on and so forth. They don't have to worry about provisioning clusters, managing infrastructure, so on and so forth, right? And I think this is the general trend, that you see, right? Customers really don't want to think about provisioning things, managing things. To Jay's point, they want to think about where are your best engineers spending time, right? And to your point about open source mattering, I think certainly this does matter beyond just core infrastructure teams that are thinking about the data architectures and so forth. Because if you think about how big enterprises, even medium and startups, think about servicing their data teams, they want to provide the best tool for the job, whether this be might be proprietary or an open source stack like Trino Presto or Spark, right? So in that sense, open source matters, right? And I think, as in terms of what we're doing at Google Cloud, and I see this kind of across the industry as well, what you want to make sure is that these systems, can plug and play and interoperate well together, right? So this is what we're after with Big Lake, making sure the hard data management primitives are taken care of while providing, the best choice for customers in terms of query processing engine, storage format, storage primitives, so on and so forth, right? So it's really the best tool for the job for the data teams that are doing the work.
Got it. Awesome. And Raghu, I'd love to go to you to understand. We talked a lot about like optionality, and sort of like you touched upon how you think about the option of having like a fully managed service, easy to use, or if you want to bring your own or do your own thing. You want to support customers wanting to do both, right? But do you have these conversations? Do they come to you for, okay, help me understand the TCO? Like, if I, based on the path that you pick, like, what does that look like?
I have these conversations multiple times a week with CDOs across the board. And here's my summary. If you're talking about an Uber, a LinkedIn, different conversation. Your problems are often bleeding edge. You want to roll your own. You have the ROI on that investment to go do it. You should go do it. Hopefully in open source. On the other hand, the enterprise customers I talk to, they build cars, they build planes, they do chemicals, they do pharma, okay? And data to them is a means to an end. They are not thinking of building their own engines. That's not even a conversation. They are buying. Even if they use an open source engine, they want a managed service. They want support. Okay, they will buy Confluent. They will not roll their own managed service using open source Kafka bits. Okay, so at some level, the conversation begins not with should I buy or build, but what should I buy? And here, the second point, the importance, no one necessarily wants to run a piece of open source code, but they want to be able to. And the reason is, as long as they use that as a principle in any piece of software they do buy, they know that if they get unhappy with that vendor, they have the optionality of picking another vendor who can replace that same open source component. Okay? But what is increasingly happening is, I'll go back to a point Kapil made. It's important to use the right tool for the right task. Analytics is not just queries. And even when it comes to queries, it's not just SQL. I mean, here's a little tidbit for you. The single most widely used internal engine at Microsoft for analytics, it's not any flavor of typical SQL. It is log analytics, queries over telemetry. As you can imagine, our DRIs, our service operators face a flood of such data. So you have a variety of query engines. You have reporting, which is huge. You have ingestion. You have machine learning, data science. All of this is part and parcel of analytics. The challenge our customers have is, do I buy a managed service for each of these? How then do I deal with the fact they each have different standards, modalities for storing data, metadata, for governance, for management, for sharing, for access control, for DLP, for failovers, BCDR, for private links. By the time you think about enterprise requirements, in getting all this stuff taken care of, it's a nightmare, right? So what they are looking to buy is a place where they can go focus on getting their data in and dealing with their business logic across the full spectrum of capabilities I'm talking about. And so the buy they're talking about is, which integrated suite should I buy, right? And that's where, beyond just giving the right tool, you have to think about the right end-to-end experience. That's another level of integration, right? And that's the difference in approachability, accessibility that the right experience makes, and underneath the right tools, and underneath the right pluggable surfaces based on open standards, formats, APIs, right? Really, we are evolving, I think, as an industry to a risk architecture for a unified analytic portal. And what people are asking about is, which one of those do I buy?
Got it. Got it. That's actually very thorough. So that's like, you've basically given us a blueprint and like a matrix to even like navigate this. So thank you so much. I think our audience will definitely appreciate this. So with that, I think we had some like very deep, intense discussions here, and we are in November, so the new year is not very far away. So time to focus on the future, and kind of like go around and see what everyone thinks it holds for the industry and what everybody's teams are working towards, right? So I want to start with Praveen. Praveen, what are the most pressing data challenges facing Uber in the next few years? And what advice would you give to an organization, let's say the next Uber starting today, about leveraging open data infrastructure, or anything, planning better towards the challenges that you already solved?
I think it's pretty apt because right after this, I need to go to a planning meeting that time of the year. But I think, so first things first, right? Things that you guys talked about, build versus buy. I think I would say I'm exhibit A, because operations is really hard. and it takes a lot of energy and time and resource investments, right? Especially on the data infrastructure side of the world. And to what Jay said, I'm always looking at what are my best engineers going to be put up at, and what is that business impact we're going to have, right? And there we run a business, right? You're not in the business of running data infrastructure, you're in the business of running Uber, first of all. But having said that, we invested a lot in certain areas, and we have a lot of unique needs, and we continue to invest in those. And what I'm looking at the future is where are the places I can get efficiencies, right? One of the examples that we know that some of you guys know is I migrated one of our core fulfillment where matching happens to Cloud Spanner. And the reason is I needed a inter-region sync replication, because when you don't want, when region failovers happen, to have two drivers come and pick you up. We have those kind of situations as well, right? Because of data coming in late. So we were not interested in building that because it's a pretty complex one. It's not just about database. It's not about just Paxos. It's about low-level networks between, and the network pipes between regions and zones. So we moved to Spanner. I think we are very happy with that, except Justin, you need to help us with a little bit of cost there. And anyways, I think that's one of the angles, right? The second thing, which I think what I'm really interested in.
See what's happening? These former builders are becoming good buyers. They're negotiate their pricing all the time.
I've become a good negotiator on that. And the second thing I would say is what the biggest challenges we're facing is democratization of the data, right? We're not like, we want to spend a lot of time on the upper levels of the data. And our problems has been, simple things like a metric definition is not standardized. And across the world, people use same metric in different ways. And how do I bring them together? Because we make big decisions on that data, right? On the metrics and definitions. And then this is where we're investing a lot on how do we standardize even on the derived data side of the world, and then being able to use the metadata properly to reason around it and so forth. So a lot of investment in that space, because those are big decisions we make based on those metrics. And the third is we are moving to cloud, and the major reason is, yes, there are certain things we're going to run ourselves, right? Our data lake is going to be run ourselves. It's going to be a single source of truth. But we need to be able to leverage the latest cloud solutions for our emerging products. Otherwise, we'll be left behind, right? A lot of startups will have a competing edge if you don't have. And as you guys know this better than me, as how fast the evolution is happening. So we're migrating to cloud, and then we'll have this single source of truth data lake, and then being able to leverage then for certain emerging products, the latest cloud solutions.
Amazing. That looks like a lot of amazing things to build, to look forward to. I want to go to Justin at Google, and not a lot of thinking time for you on this. $1 billion question. Do you think Lake and warehouses are going to converge?
So, I mean, if you look across the industry and what we've talked about already in this panel, I mean, I think warehouses and lakes have already converged in meaningful and interesting ways, right? If you just think about what we talked about so far, right? I think it's standard, today to look across, the cloud offerings, and see, at least analytics offerings in particular, right? And to see an architecture that supports a serverless consumption model, an architecture that cleanly separates compute, storage, maybe more components, right? Such as catalog and so forth. With open source engines and open formats being used meaningfully across these ecosystems, right? And this really isn't by accident, right? If you look at how data warehousing and data lakes have evolved over the past, say, 10 plus years, there's several commonalities, like large data sizes, need for scale, so on and so forth, right? From the beginning, I think data lakes brought about, new interesting workload types, with the advent of cheap object storage, different types of systems being built around object storage as the hub. Along came, AI ML workloads on unstructured data as well, and working, structured data working over open formats, right? But if you look at kind of where customers want to go, right, it's natural that, customers, that are especially enterprises buying these services, they want these things to converge in meaningful ways, but still having, the freedom to kind of plug and play and choose at each layer of the stack, right? So at the end of the day, you have data assets that they want to manage and analyze, and ideally they see things under a single umbrella, right? But not necessarily disparate systems and so forth. So this is where I think we've evolved in meaningful ways already, and I think this will just continue.
All right. That's That's nice to hear a bigger kind of like first bigger lens view of this. Justin, Starburst has capabilities in hybrid and multi-cloud, lake federated querying, right? Do you think this is all converging to querying a data lake using, this kind of like converged sort of architecture that we just discussed? What do you think is the single biggest change that's upon us in the next few years in terms of data architecture?
So I definitely think data lakes will have the largest amount of gravity because of the TCO benefits of open formats and low cost storage. But having said that, I don't think anything will ever all live in any one thing, I guess is what I would say on that, right? Like, I think there's always going to be other database systems. Mike Stonebreaker famously said there's no one size fits all database system. There's always going to be purpose-built systems that serve particular purposes. And so, that's why we think federation is a required capability, because your architecture will always evolve. Even if 80 or 90% lives in a lake, you're always going to have other systems. I also think on the point about hybrid and cloud, certainly there's a lot of momentum to cloud, and we're very bullish on that as well. But I also think there will always be data on-prem too. And there's a lot of interesting excitement around building object storage on-prem and creating cloud-like architectures, but in an on-prem world. And so I think that will also be part of our future. So I think that, heterogeneity, I guess I would say, will to me is here to stay, even though I think data lakes will play a larger and larger central role.
Got it. Awesome. Kapil, I have a rather interesting question. So, close to, kind of like your role at LinkedIn, close to open source projects coming out. What do you think are some of the open source data projects that we need to build? Are they are like waiting to be built in the next 5 years? So if any eager engineers are watching, you may want to take some notes, and you can be the next Jay here.
So I'm going to start with the note of caution first, right? So if anyone out there is thinking about building an open source project for the sake of building an open source project, please don't. Right? So every successful open source project I know started with a real dying need for that thing to exist, because nothing else literally would work. And success in open source, I think, many people on this panel are more experienced in this than even I am. Right? Success requires both time and commitment in that open source. I think a lot of people might want to do open source is like thinking, oh, you're going to get extra resources that are going to test and contribute code. And you go getting that level of success where you hit that is one, relatively rare, but even getting there requires a ton of investment, right, to build that community in the first place. Now, having said that, I think there are a bunch of areas that I think are exciting, and we'll see, and I hope they see a lot of open source activity, right? So going back to our earlier topic of the diversity of query and compute engines and how we can benefit from like disconnecting sort of the data and the metadata layers. I think that need for open and cross-compatible data formats, I think that momentum, I think, and hope will continue to accelerate. I think we know you guys announced one table earlier this year. I don't know whether that's been open sourced yet, but that's something that I would sort of look forward to with excitement. I think in general, I think the data management space, broadly speaking, I think there's a lot of activity that I think is promising, right? Getting a little more specific, I think, areas like data governance, like privacy, quality, related areas of data catalog discovery. I think, and LinkedIn, as you know, open source data hub in the space. It's found some open source traction as well as commercial push. And I think with evolving regulations and the focus on privacy in general, I do expect that's going to be a pretty active area in general. And last but not least, I think a third bucket I would say is in the AI space in general. There's definitely a lot of focus today on sort of large language models, right? Like every day that seems like there's a new open source model that shows up. But besides just models, there's a lot of tooling around managing that entire life cycle that that I think will see a lot more activity in the open source, right? So I think the next year and a few years are going to be pretty exciting from that perspective.
Thanks for sharing that. It's interesting that you mentioned AI, and I want to go to Raghu here and tap into the collective wisdom around this. I don't think many companies were expecting to prepare an AI or LLM strategy when the year started, actually, right? So, what are quantum computers next? Are we going to suddenly have them? What do you think are some of the most impactful technology shifts, fundamental changes that you think are going to happen in the next 5 years? And
speaking of AI, every time I've done a review with Bill G over the last many years, invariably he ends with this question: when can I actually query your database in English? And until now, I always said, that's a great question, Bill, which is what you say when you don't have a great answer. This time around, I showed him an assistant, a co-pilot in Microsoft jargon, right? And that's something I would point to as a direction. The databases of tomorrow are going to be very, very different from the databases we have been used to. No one will ever write a SQL query from scratch anymore. No one will ever tune a database from scratch anymore. No one will build a data pipeline from scratch anymore. I mean, I can keep going on and on. In a nutshell, if you use a database, your job description just changed. Okay? Now, that assertion, while I'm pretty confident, it's not yet real. Building a cool demo with a foundation model is easy. Building something that works reliably with guardrails is brutally hard. That's going to keep us busy for the next several years. But make no mistake, that is going to completely change what you mean by a database and how you work with the database. And as a bonus, I'll give you one more thing I think will be very different in 5 years. 10 years ago, 15, 20 years ago, if you talked about building a specialized database machine, people who tried that 3 decades ago and failed because Intel's chips, AMD's chips kept getting faster and faster, quicker than the specialized hardware, they would have laughed in your face. Database machines are a bad idea. I don't think that's true anymore. Moore's law has plateaued. And custom chips for GPUs, for example, APUs, there are lots of venture-backed companies exploring this, okay? I think database machines are going to be alive and kicking over the next few years. Which particular technical pathway or which combination of pathways work best, who knows? But that's my second prediction for the day. Database machines are right again.
Right, all right, that's interesting. So I really hope the database, the database engineer jobs are still there, because that's the only thing I know to do. So let's really hope.
I think you're safe.
So I want to go to Jay here to wrap. So do you see batch and stream processing converging in the next 5 years? What does that look like?
Yeah, I think it's happening right now. It's happening kind of from every direction. Kafka is getting better at kind of sending data out to object storage, and so that kind of stream and storage is happening. Systems like Hudi are doing a great job of some of the incremental ingestion and processing. Even the kind of database world is getting better at ingesting and processing streams on the way in instead of just querying them on the way out. So the change data capture world for databases, that's really kind of becoming a first-class citizen from almost a funky hidden trapdoor on the side of the database. That's becoming a very serious interface to these systems, and it's becoming needed. As all the parts of a company interact together, that ability to publish out some stream of what's happening and have other things react to it is incredibly important. And then the idea of how you work with that kind of data is really advanced. I think Flink has done an amazing job at kind of bringing together stream processing and batch processing and really kind of reimagining streaming instead of as some kind of niche thing as a kind of generalization of the batch world. And that opens up a lot of this to be able to build applications that you can kind of run on some static data and then have them go off and keep updating as the data changes. So yeah, I think that whole world is coming into being now. We're very happy at Confluent to be working in that space, and there's like really exciting things happening. But I do think that's a really central piece in the data landscape, and it's something that's happening in almost each of the data estates. Some adjustment to the streaming world, either to be able to produce streams or consume streams or process them or whatever. And I think that's a great change. I think it brings a lot of the sophisticated use of data out of these kind of old end of the day batch jobs that are kind of a bit of an odd hangover from the mainframe era, and brings it right into the operation of the company, which is where it can have the impact.
All right, got it. And that's amazing. So for my neck of the woods, nobody talks about batch ingestion anymore. So that's like a big change. And 5 years ago it wasn't the case, right? With that, we are at the end of our today's panel. It flew by so fast, and how deep this conversation was. I'm just going to take a break and collect my thoughts and sort of assimilate and my learning. So should you. So thanks so much for joining us, and I really thank our panelists for sharing their wisdom and experiences with us, and have a great rest of the day.
Thanks for a great job moderating, Vinoth, and thank you, Mike.
Thanks, Vinod.
That's fun. Thanks.